let's talk about here in 6.2. So we're starting 6.2. Let's talk about the unit circle and what these values mean. All right. So the basic, most fundamental rule I want you to know is it's all about, let's do the cosine of 30, for example. Somebody asked me, what's the cosine of 30 degrees? What's the cosine of 30 degrees? Well, first off, 0 degrees is right here. See the 0? 30 degrees is right here. Here's the dot. Pi over 6 is the radian. That's what I like about this. It's got the radians and the degrees all right there for you. So, okay, so what's the cosine of 30 degrees? Do you know the answer just by looking at that? So one of those two numbers? If so, which one? Yeah, the cosine is always the x one, and the sine is the y. So the cosine of 30 degrees would be root 3 over 2. The sine of 30 degrees is the half. Now I'm going to explain why and what all those numbers mean in a minute. But first off, let's get that idea fundamentally really clear. Cosine is always the x-coordinate of the dot. Sine is the y-coordinate. So wherever you're at, say you're right here. Oh, this is the unit. What does unit mean? 1. This is the 1 circle. When we call that the unit circle, we mean radius 1, meaning how far from here to there? That's radius 1, radius 1, radius 1. The radius of that circle is 1. That's the 1 circle. That's the unit circle. Okay? So what? Well, that means wherever you're like at a dot, say at 30 degrees, you're at the edge of the circle for an angle of 30 degrees. You open up 30 degrees and you go to the edge of the circle. Your x-coordinate will be your cosine. Your y-coordinate will be your sine. So everywhere you move around that circle, your x-coordinate is cosine, your y-coordinate is sine. So you want to think about sines as heights. Sines are heights. So start thinking that way. They're going to give some good questions in this section that force you, really test if you understand and feel. I want to get in tune with your math feelings. This is like a sociology class. We're tapping into our math feelings in here. You have to feel. They're going to give you some questions where you can't use your calculator, because they'll be on part 1, and you can't answer the question unless you feel the unit circle, because it's all about feeling heights and getting the idea from heights. So know that sines are heights, cosines are over, because cosines are x, right or left, sines are y, up and down. Sines are heights, cosines over. So any dot you're at. Now, with that in mind, it's really actually very easy to memorize this whole unit circle. And I don't have a good memory. So if I say that it's true, if you just remember, I'm not going to make you can put it on your card, but if you just remember small, medium, large, small, medium, large values. There's just 3 numbers other than 0 and 1. 3 other numbers that we use all the time. It's 1 over 2, root 2, root 1, root 2, root 3 over 2. That's pretty easy to remember, right? Root 1, 2, 3. Small, medium, large, like ordering a soda. I'll take a medium, right? Root 1, root 2, root 3 over 2. Small, medium, large. Now, what's the square root of 1? That's just 1. So we don't need the root on that one. But I want you to see the pattern. It's like the root's really there, but root of 1 is just 1. So it's 1/2, root 2 over 2, and root 3 over 2. Small, medium, large. Now, what do I mean? I mean, let's look at the locations on the unit circle. Say that you are right here at that 30-degree spot again. How do you get to that 30-degree spot? You go over a lot, up a little. Like XY coordinates, you know? XY always comes from the origin. Over, up. So I went over a large amount, up a small amount. You see what I mean by that? I went over a lot further than I went up, because that dot is below the middle. Whereas, say I went to this dot here. This would be over a small amount, up a lot. Over small, up large, wouldn't it? Now, what do I mean by small and large? All that? I mean these, small, medium, large. So in other words, this is over small, which is 1/2, up large, which is root 3 over 2. That's why his x-coordinate, his cosine, his sine is over 1/2, up root 3 over 2. That's how they're getting at. Over small, up large. Do you see that? Whereas this one here is over a lot, over the large amount, over root 3 over 2 is x-coordinate, and his y-coordinate is up a small amount, only up 1/2. Again, that's his cosine and his sine. Cosine is always, they're reversed. You'd think sine would come first, but cosine comes first, then sine. And then how about the one in the middle? How about the one right smack? That's right smack in the middle of the first quadrant, isn't it? 45, it's half of 90, right in the middle. Guess what he is? Small, large, medium, huh? Middle, middle, medium, medium. That's why they're both root 2 over 2. Notice the medium is a loner. He only hangs with himself. Or they're twins, or whatever analogy works for you, right? Root 2 over 2 with root 2 over 2. Whereas the small and the large are friends. They go together. See how all the values all the way around the circle? See how the small and the large are always together, but the medium goes with himself only? Right? And the medium is always in the middles. Do you see that? Because it's in the middle. It's over middle, down middle. It's in the middle. Isn't it? Do you see that pattern? All the middle of every quadrant is going to be both mediums. Because you're over a medium amount, down a medium amount. Yeah, look at this spot right here. How do I get there? How do I get to this spot? I go over a medium amount, down. That's why it's positive and negative, because it's down. See the x, y? That's cosine, sine. So what's the cosine of 315 degrees? Root 2 over 2. What's the sine of 315? Negative root 2 over 2. You see how those values come about? It's all about your position on the unit circle. So it's all about over and here. Let me do one more here. I need a fresh unit circle. That was all marked up. Okay, so fresh unit circle here. So therefore, what about how about straight up? What if somebody asked me 90 degrees? Well, 90 degrees is straight up. There's the x and the y coordinates. That's a point. From the origin. Think about graphing. How do you get to that point? Over 0, up 1, right? That's why that's x, 0, y, 1, which is cosine, sine. So what's the cosine of 90 degrees? 0. What's the sine of 90 degrees? 1. It's the y value. That's how they're getting all the values. Does that make sense on that? That's the unit circle. That's what I would use, suggest that you use as you do your homework. Have it open in a window or on a thing. Okay, so with that in mind, let's, one other thing. Well, no, let's put that off. Good enough. Let's go do some homework. So, okay, so here we go. So here's the first question then, with all that background. So they're saying there's a point on the unit circle. They're giving me the point, and they're saying I want sine, cosine, tangent, cosecant, secant, cotangent. They want it all. So, all right, so how do we find the sine? So remember, the x value is always cosine. The y value is always sine. It's a fundamental, most important thing to remember. Cosine is x, sine is y. So what's the sine? Well, it's a half. It's just sitting right there. What's the cosine? Well, it's negative root 3 over 2. It's the x. It's just sitting right there. Nothing more tricky than that. Now, tangent. Anybody remember the definition of tangent? Yeah, you remember from your trig class? Sine over cosine. Yeah, so all the other 4 trig functions, tangent, secant, cosecant, cotangent, they all come from sine and cosine. All the trig is really sine and cosine. That's it. If you can get sine and cosine, you get everything else. So just focus on sine and cosine. That's why in that unit circle, all I have is sine and cosine. Because that's all you need. The other 4 all come from sine and cosine. So like tangent, he's just sine divided by cosine. So I just go, okay, take sine divided by cosine. Like that. Now, how do I simplify that? Yeah, that'd be good. I'm just going to do the same thing every time. I'm just going to flip that up. Remember, we just flip these upside down, and it becomes a half times negative 2 over root 3. Remember that? So I just grabbed that thing and flipped it up like that. And then how can we simplify? The 2's cancel, and you get negative 1 over root 3. But we can never leave a root on the bottom. Remember that? So multiply top and bottom by root 3, and you get negative root 3. Oh, it's on the bottom. Root 3 is root 9 is plane 3, huh? There we go. There's the tangent. Negative root 3 over 3. That good? Question?
Tangent 90, that was the undefined one, right?
Tangent 90. I didn't talk about it, but tangent sine over cosine, cosine 0, that would be undefined. Uh-huh. Okay, so let's keep going. Now, so we did 3 of them. We did sine, cosine, tangent. Now let's do cosecant. Anybody remember what's cosecant? CSC? Yeah, it's upside down to sine. Cosecant is 1 over sine. You just flip the sign. So just take 2 over 1, flip it. 1 over 2, flip it. It's 2 over 1, or it's, I guess, just 2.
Negatives and positive wise, they stay the same, right?
That's right. Signs stay the same when we flip the things. Yeah, that's right. All right, let's do, next let's do secant. Secant is upside down of cosine. So just flip cosine. It's negative root 3 over 2, negative 2 over root 3. But we can't leave roots on the bottom. So multiply top and bottom by root 3. Negative 2 root 3 over plane 3, right? Root 3, root 3, root 9, plane 3. There's secant, last one. Cotan, you know that's upside down to tan. So I'm just going to flip the tangent. Well, and you know what the easy way to flip? I could grab this last one and flip it, but then I would have a root on the bottom, and I'd have to get rid of that, which you could do. But why don't I just flip this one back there when the root was still on the bottom, then it'll go to the top. You know what I mean? Make it root 3 over negative 1, which is just negative root 3. We did it. We did all 6. How are we doing? You digesting all that? Is that making sense? I'll give you a second. Any questions I can answer? We good? So sine and cosine are just, cosine is the x, cosine is the x, sine is the y, and then all the other 4 come from sine and cosine.
How'd you get cotangent?
Cotangent, I flipped tangent. Cotan is upside down to tan. But I didn't grab this one and flip it, even though this is tangent. Because if I flipped it, that root would be in the bottom. And then I'd have to fix it. I mean, you could have, but then you have to fix that. I said, look, why don't I go back to here? This is also tangent before I simplified it. And just flip that one. So I flipped that one. That was a little easier. That way I didn't have to deal with the root in the bottom. Are we good? So those are the 6 trig functions. They all come from sine and cosine. So definitely put those definitions on your 3x5 card. That sine is upside, cosecant's upside down to sine, secant's upside down to cosine. I think you know tan and cotan are upside down. And that tangent is sine over cosine. So you want to have this and this and this on your 3x5 card, I would think. Right? Cosecant is upside down to sine, secant's upside down to cosine, tangent is sine over cosine. Okay, tangent of 4 pi. Let's do unit circle. It's all about unit circle. So let me give you a second. See if you can find 4 pi. I'll give you just a second on that. How y'all doing? Where's 4 pi?
0.
Yeah, it's at 0. You know that? This is 0 here. If you go all the way around the circle, that's 360 degrees or 2 pi, first off. Do you remember that from your trig days? All the way around. Remember, we have degrees and we have radians. You comfortable with degrees and radians? You remember them a little bit? Pi, here's the connection between radians and degrees. Pi is how much? Pi radians is how many degrees? 180. Do you remember that? Pi is 180. Pi radians is 180 degrees. So pi radians is 180 degrees. Therefore, all the way around 360 is 2 pi, isn't it? It's 2 times 180. So what? Well, if that's 2 pi, so if you start here and you go, okay, I went all the way around the circle, ended up back at the same spot. How far did I rotate? 2 pi. Well, then do it one more time. Another 2 pi, 4 pi. You're still right there. So 4 pi, 2 pi, 0, they're all the same spot. It's just you've gone around more than once. So what? It's all about where you end up. Does that make sense on angles? It's all about where you end up. So 0, 2 pi, 4 pi, they all end up at the same spot right there. Okay, so what? Well, what are the coordinates of that spot? How far over? How far up? Like, think about graphing. Here's the origin. How far over? 1. Remember, because it's a unit circle. Radius 1. So if you go to the edge, it's always 1. 1 over, up 0. You with me on that? So that's cosine and sine. Cosine and sine. right? Because cosine is always the x-coordinate, sine is always y. What do they want? They want tangent. So tangent of 4 pi is, remember the definition, sine over cosine. So sine is 0, cosine is 1, 0 over 1, 0. We're done. No calculator needed. Did y'all see how we got that? So 4 pi, all the way around is 2 pi, all the way around again is 4 pi, so you end up right where you started. And that's the point over 1 up 0. And tangent is sine over cosine. 0 over 1, 0. Good questions. All right, cosecant of minus pi over 2. All right, so cosecant. You know what I would do with that right away is I would convert it, because I don't think about radians as natural as I do degrees. Just stick a 180 in there. 180. We talked about where degrees came from, right? No? Sorry, I have the two sections. I get confused. Like what? Why? All the way around a circle is 360 degrees. Why? Did we talk about that? Okay, real quick. Why? Why is all the way around a circle 360? that'd be circular logic. It's funny we're making circles, but you know that technically is circular logic, right? You're saying you want to know why that's 360? Because halfway is 180. Well, no, halfway is 180 because this is 360. And the question is, where did either one of them come from? Right? Yeah, exactly. That's where they made it. So they just made it up. Again, I'm trying to let you know in math and science what's just made up and then what has to follow logically. That's just made up. They could have said like all the way around is a nice even 1,000, or all the way around is a nice even 100, or whatever. But they made it up because back when they were first doing angles, the first uses were navigating ships before we had, GPS and all the fancy stuff we have now. They would look at the stars, they would navigate by the stars, and they would use their little instruments to measure angles of the stars and how the stars are moving. They know where they're at. Anyway, back then, their closest estimate to our orbiting the sun was 360 days. We know a little better now. It's closer to 365. Anyway, they just made that up. All the way around 360. They said, all right, all the way around is going to be 360. Made that up. All the other angles, therefore, come from that. Okay, so what? Well, then, pi, see how I just stuck in 180? Remember, pi's right here. Pi is 180 halfway around the circle. So whenever you see them give you a radian angle, so the radian system just says all the way around is 2 pi. So there's the degree system and the radian system. There are just two ways to make an opening amount, right? If I come over here and open the door at a certain angle of opening, right? That's what an angle is, an amount of opening between two lines. And there's two systems. There's actually a third system called gradient, but we're not going to do that. So two systems that are commonly used, angle degrees and angle radians. So the degree system, 360 all the way around, radian system, 2 pi. So whenever you see pi, pi is the same as 180. So I take that pi, put in 180. So this is really the cosecant of negative 90 that they're asking me, huh? So you always got to find out where it's at. So where's negative 90? How do you do negative angles? You go down instead of up, don't you? So in other words, this is 0. And why 0 start there? They made it up, right? Just like we drive on the right side of the road in North America. They just said, they could have made 0 straight up, like a clock or something. But they didn't. They started right there. So that's 0. They made it up. Positive angles go up. Negative angles go down. So negative 90, right there, huh? Negative 90 straight down, isn't it? So what are the coordinates, like graphing x, y, for that dot? What are the coordinates at that point? Over 0, down 1. Cosine, sine. Well, now, what's cosecant? What's the definition of cosecant? He's the upside down of whom? He's the upside down of sine. So what's the sine? Negative 1. So this answer is also the upside down of negative 1 is just negative 1. There it is. Good. Unit circle. All is well. I'll keep moving. Cosecant is negative 1. All right, so sine 45 plus cosine 60. How do we do it? Yeah, let's go to the unit circle. Take a look. Take a look-see. All right, so I would just look on here. So again, I need sine of 45. So this is what I hope you'll be doing in your homework. Is what you put on your 3x5 card for the test. Find 45 degrees right there. Cosine is the x, sine is the y. So what's the sine? Root 2 over 2. They're both root 2 over 2, right? It's a medium. They're both root 2 over 2. So this one's root 2 over 2 plus. Now, cosine of 60. What's cosine of 60? Here's 60 degrees. Cosine sine. Cosine's half. Why? Because that's over a small up a large, isn't it? Over small up large, only over a half. Cosine is over. Sines are up and down, right? That's why the cosine's a half. It's only over a little bit. The dot at 60 is only over a little bit, isn't it? Cosine's a half. So cosine's a half. So there we go. You put them together, you have a common denominator. Boom, done. They want it that way. They don't want decimals. That's what they say there. Exact answers. No rounded decimals. No calculator. Good on that? Questions? Okay, so they want the sine of minus 300 degrees. The sine of minus 300. Excuse me. Again. So we got to really find where that is on the unit circle. Oops, my circles aren't the best. Okay, so see if here's 0. You start right here at 0. So do minus 300. Remember, that means go down, huh? Go down 300 degrees and see if you can find where you end up as a regular angle, as a positive. You want to find it in normal, positive language, right? So go down 300. You know how to do that? Is that making sense? So you know how these work, right? This is 90. Remember this from your trig days? 90, 180, 270. Positive. I'm going negative. So I'm going to go negative 90, negative 180, negative 270. It's going to be about right there. Right there. It's going to be a positive 60 degrees. So this is the angle. Negative 300. Did y'all see that? Negative 300 degrees is the same as positive 60. Why? Because it's 360 all the way around. So if this is 300, I just got 60 more to go to finish the loop, don't I? So this must be the same thing as positive 60. It's the same place. It's the same ending point. To say I started at 0 and I went negative 300 is the same thing as saying I started at 0 and I went up 60. Either way, you'll end up at that same dot. It's all about the dot you end up at. They call that the terminal side, the ending location. That's all that matters, is where you end up and what the x and y coordinates are at that dot you end up. So let's go to the unit circle and find positive. This is really positive 60 degrees. Same ending spot, isn't it? So we just go to the unit circle. Say, okay, positive 60. Where is it? Oh, it's right here. Cosine sine. I want sine. Root 3 over 2, positive 60. Right there. Root 3 over 2. Then they want the other 6 trig functions. I'm going to go dot, dot, dot. You just get the other 6. Sine and cosine, and then do the rest. Is that good? Let's find your ending spot there. All right. Part 2, we'll use your calculator. So, cotan of pi over 20 on your calculator. You guys have calculators? How do you do cotan? There's not a cotan button. How do you do cotan?
1 over 10.
1 over 10. You have a tan button, right? Maybe some calculators have a cotan button now. I don't think so. 1 over tan. Maybe so. 1 over tan, pi over 20. Hit the buttons. Oh, now is that a radian angle or a degree angle? Which system is that? Radians, huh? Because there's no degrees anywhere. So make sure you go to mode. You know where the mode key is at the top of the calculator? Second, right at the top, second one over is mode. Make sure you're in the radian. Hit mode button and go down and see where the third one down is radian or degree. Make sure you're in radian mode. And then hit 1 over tan. And you got to hit the pi button. Don't just put in 3.14. You have a pi button. You got to be more accurate than 3.14. You have a pi button, which is located above the up arrow on the right edge of the calculator. So the right edge, the up arrow, just above it, there's a pi button. Hit second pi divided by 20. And I'm getting 6.313. They want 2 places, so 6.31. Able to get that? All good? Yeah.
On your test, will like the answers be like all radians, or will it show like radian, what you can get in radian?
So there'll be some questions with radians and some with degree. So the same question wouldn't have multiple. Am I answering your question?
Yeah, so like if one of the answers needed to be radians in the options, would it like have what you would find?
Yeah, I'll explain how you know that as we go on. But right now, you plug in angles, which are radians or degrees, and you get out answers, which are neither radians nor degrees. They're numbers. So we'll talk more about that as we go. I mean, especially when we get to inverse functions in 7.1, because then they switch, and I'll talk a lot about how you know where they're at. Yeah, but right now, angles, what you put into a trig function, think about a toaster. What you plug in is angles, which is radians or degrees, and you get out answers, which are just plain numbers. So this is just plain number. This is neither radians nor degrees. It's just a plain number. It's the answer.
You mentioned like inverse functions. So if like you plug in, say, like you trying to do cotangent, but then you do the inverse.
Answer this question. So they're asking me, find the exact value of sine 50 plus sine 130 plus sine 230 plus sine 310. Notice that none of those are our memorized values. In other words, if you go to the ones that are on our unit circle picture are ones like 30, 45, 60, 90. It's not 50. 50 is not there. Right here, let me show you. What am I talking about? Here we go. Look at here's the unit circle. I don't see 50. Here's 45, 30, 60. Where's 50? 50 is not there. And also, now you think, well, I can do it with a calculator. You could, but this would be on part 1. No calculator. You can do this without a calculator if you feel the unit circle. So, no calculator, not directly on the unit circle, but if your feelings are in tune with the unit circle, you can answer this question. Let's draw. Definitely need to draw. Let's draw what we got here. So, unit circle and 50 degrees. Is what they're giving me. Now, where about is 50 degrees? Well, it's a little past halfway. 45 is halfway. 45 is probably right there. So 50 is just a little above that, right? Right, this is 0 over here, right? 50 degrees. Okay, great. So what? Well, let me jump over here to the 310. You'll see why I went to the 310 in a minute. Where's 310? Well, 360 is all the way around, so it's 50, notice, below. And this is 50 above, isn't it? Yeah, well, let's think about it. You think, well, yeah, okay, that's a cute trick and everything, but how's that help me with the question? Well, what's the fundamental, the golden rule of trig is cosine is x, sine is y. That's it. Forget everything else, remember that. Cosine is x, sine is y. Cosine is sideways, sines are heights. What do you think about the height of that 50-degree point? How high up he is, and what do you think about the height of that other one?
They're the exact opposite.
They're the exact opposite. Now, why am I talking about heights? Because they're saying sine. That's all you think about when they say sine. Heights. They mean, what's the height? What's the height? What's the height of this point at 50? What's the height of that point? That's what it means when they say, what's the sine? So you know that, like, deeply, right? So somebody wakes you up in the middle of the night. They say, what's the sine? You go, height. Sine is height. And cosine is over, isn't it? So then, what is sine of 50? What is the height at 50 plus the height at 310? Whatever height this is, call it positive y. I don't know what it is. But whatever it is, this one is the opposite. It's negative, that same thing. So what is this, which I don't know, plus that, which I don't know but is the opposite, add up to be? 0. It's got to be. I don't know what either one of them is, but they're the opposites. Now, is that true for the other two as well? It totally is. Let's find the other two. 130, where's that? Well, that's 40. It's 90 here, huh? So that's 40 past the 90, 130. And where's 230? Well, if you go 270 and you go 40 back, you're at 230. See how positive, whatever that one is, they're the opposites. They're 0. These two make 0. What's the answer to this whole problem? 0. Got to be, huh? See that? So if you're picturing on the unit circle, you know it. All right. You're in tune with your... Okay. So They are giving me tangent of theta is 4, and then they're saying f of theta plus pi. Now, what? I don't know why they, but whatever. They're saying f of theta is the tangent function. So when they say f of theta plus pi, they're saying tangent of theta plus pi. Sorry, I'm getting scribbly. You're with me. So when they ask me, which is what they're asking me, what is f of theta plus pi? What is f of theta plus pi? It's tangent of theta plus pi. Okay, so they're really asking me, what is tangent of theta plus pi? I know the tangent of theta is 4, but what's the tangent of theta plus pi?
It's just going to be the same thing.
How do you know?
Because in the quadrant 2 passes, it's going to be the same thing. Like, based on the
Yeah, you're right.
value, I don't know how to explain it.
The period of tangent and cotangent is pi. Important fact to remember. What does that mean? Let's talk about. Well, you know, and then the other trig functions, let me write them down too. The period of the other 4, sine, cosine, secant, cosecant, is 2 pi. Are you tracking with me? What does the period mean? Well, it means how long till it starts repeating itself. How long is it cycle till they're all repeating the same numbers again? Well, you know that if you go all the way around the circle, you're going to be back to the same spot, won't you? If you're on the unit circle, say you're here or wherever, and you go all the way around again, say you're at 30 degrees, and then you add 360, now you're at 390. That's the same spot, isn't it? That's the same ending spot. To say, I'm going to go to the angle 390, or I'm going to go to the angle 30, that's the same spot, because it's just 360 later. It's just a full circle later. Is that good? Is that making sense? So my point is, the period of these trig functions is 2 pi, but which you probably already guessed. But the weird thing about tangent and cotangent, they repeat after just half a circle, pi. Pi is just half a circle, 180. So when they ask me half a circle later, it's going to be the same answer. It's going to repeat the same answer, half a circle later. So you want to put that in your 3x5 card. That will be tested next, whatever it is, week after next on our exam, knowing the periods of these functions. You need to know that for calculus. So the period of tangent and cotangent, they start repeating their values after just half a circle. The other 4 trig functions take a full circle, a full 2 pi, to begin repeating their values again. Okay, so let's try that one. So what does that little circle in the middle mean? Do you remember? It's been a while. We've had it. What is it? Anybody know?
It's the
Yeah?
right?
It's what's that?
Dot product.
Oh, no, not that. That's in calculus. Yeah, no, it's not that right. That little circle, yeah, it means one function inside the other. It's composition of functions. So in other words, it means this. It means stick the h inside the f. That's what that little circle means. One of them goes inside the other. Well, we had that 2 months ago. So, okay, so what? Well, you start with the inside. Got to figure out what is h of pi over 6. Well, and then we'll leave the f for a minute. What's h of pi over 6? Well, here's the h function. The h function says anything you give me, I'm going to multiply it by 2. So you give me pi over 6, I'm going to go 2 times pi over 6. That's what I'll do, says the h function. 2 times pi over 6. We good so far? And then, put this over 1. And cancel these out. 3. And so this is f of pi over 3. How is this for you guys? Is this easy stuff? Let's review. Sorta? You remember this? Rudy, Trevino, I'm expecting great things out of you. You guys have me for trig, so I'm expecting you to know everything perfectly. It's all clear. All right, I hope so. I'll be calling on you. All right, f of pi over 3. I worked out the inside. The f function is the sine function, so that means sine of pi over 3. F is sine. So what's the sine of pi over 3? Now we go to the unit circle. Draw that work, we go to the unit circle, and we see what we can see. I don't know where it is. I'll put a new one in here. There it is. So pi over 3 right there. Cosine sine. What do we want sine? Sine's root 3 over 2. Yep. Root 3 over 2, done. Did you all see what I did there? So that little circle means one function inside the other. Did the inside function, which is double it, which canceled the pi over 3. F is sine pi over 3. Got it off the unit circle.